Ground rods are generally installed outside the building. Common locations include near the electric meter or service entrance, at the corners of the building foundation, and away from driveways and sidewalks. The grounding electrode conductor, or GEC, typically connects the metal conduit containing the service entrance conductors to the ground rod or rods. The GEC can be installed inside electrical metallic tubing, or EMT. In this case, a grounding bushing is required at the end of the conduit where it connects to the ground rod. The GEC may enter the meter socket if the main breaker panel is located next to the meter, but this is not a common practice in residential applications. The GEC is typically connected to the ground rod or rods using a ground rod clamp. The connection point is buried below grade. When there is no bonded copper water piping available, you can bond to the electric service equipment grounding conductor, or ESC, using a listed bonding strap. The strap connects to the main grounding bus in the electrical panel and to a water pipe, water heater, or other appropriate bonding point. In some areas, local codes may require more than 2 ground rods. The GEC should be insulated to protect it from damage. All bonding connections should be made with listed bonding materials. When installing ground rods, consider these points. Firstly, ensure that the ground rods are listed and suitable for direct burial. Secondly, drive the ground rods to a depth where the top of the rod is at least 8 feet below grade. Thirdly, if rock bottom is encountered, the ground rods can be buried at an angle not more than 45 degrees from vertical, or they can be laid horizontally in a trench at least 30 inches deep. Fourthly, the distance between ground rods should be at least 6 feet. Fifthly, protect the GEC from physical damage by running it through conduit or using an insulated conductor. Sixthly, when connecting the GEC to the ground rod, use a listed grounding clamp suitable for direct burial. Seventhly, ensure that all connections are tight and corrosion resistant. Eighthly, bury the connection points to protect it from corrosion and physical damage. Ninthly, document the location of the ground rods for future reference. Tenthly, comply with all local codes and regulations regarding grounding. When installing the GEC inside EMT, consider these factors. Firstly, the EMT must be adequately supported and secured. Secondly, use appropriate fittings and connectors for the EMT. Thirdly, install a grounding bushing at the end of the EMT where it connects to the ground rod. Fourthly, bond the EMT to the service equipment grounding system. Fifthly, protect the GEC from physical damage inside the EMT. Sixthly, use an insulated conductor for the GEC inside the EMT. Seventhly, ensure that the EMT is properly grounded to prevent electrical shock hazards. Eighthly, comply with all local codes and regulations regarding grounding. Ninthly, use appropriate sized conductors and conduit. Tenthly, be sure to use properly rated grounding bushings. When bonding to plastic water piping, consider these steps. Firstly, identify the electric service equipment grounding conductor in the main electrical panel. Secondly, select a listed bonding strap that is suitable for connecting to the ESC and the water pipe. Thirdly, clean the surface of the water pipe where the bonding strap will be connected. Fourthly, attach the bonding strap to the ESC using a listed connector. Fifthly, attach the bonding strap to the water pipe using a listed clamp or fitting. Sixthly, ensure that the bonding strap is securely fastened and provides a low impedance connection. Seventhly, protect the bonding strap from physical damage and corrosion. Eighthly, document the location of the bonding connection for future reference. Ninthly, comply with all local codes and regulations regarding bonding. Tenthly, ensure that there is adequate access for inspection and maintenance. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. Bonding connects all metal parts of the electrical system to the grounding system, ensuring that they are at the same potential. This prevents voltage differences that can cause electrical shock hazards. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding. It is important to follow these requirements to ensure the safety of the electrical system. Section 250.4 of the NEC covers general requirements for grounding and bonding. It emphasizes the importance of creating a low impedance path for fault current to flow back to the source. Section 250.24 covers grounding of service supplied alternating current, or AC, systems. It requires that the neutral conductor be grounded at the service entrance. Section 250.50 covers grounding electrode systems. It specifies the types of grounding electrodes that are permitted, such as ground rods, metal water pipes, and concrete encased electrodes. Section 250.52 covers the installation of grounding electrodes. It specifies the requirements for the size, depth, and location of grounding electrodes. Section 250.64 covers the grounding electrode conductor. It specifies the requirements for the size, material, and installation of the grounding electrode conductor. Section 250.92 covers bonding of equipment containing service conductors. It requires that all metal parts of the service equipment be bonded together. Section 250.104 covers bonding of piping systems and exposed structural metal. It requires that metal water pipes, gas pipes, and exposed structural metal be bonded to the grounding system. Section 250.118 covers types of equipment grounding conductors. It specifies the types of conductors that are permitted for equipment grounding, such as copper wires, aluminum wires, and metal conduits. Section 250.130 covers equipment grounding conductor connections. It specifies the requirements for connecting equipment grounding conductors to equipment and enclosures. Section 314.40 covers boxes and fittings. It specifies the requirements for grounding boxes and fittings. In addition to the NEC, local codes and regulations may also apply to grounding and bonding. It is important to check with the local electrical inspector to determine the specific requirements for your area. Proper grounding and bonding are critical for electrical safety. By following the requirements of the NEC and local codes, you can ensure that your electrical system is safe and reliable. The size of the grounding electrode conductor is determined by NEC Table 250.66 based on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 American wire gauge, or AUG, copper, the grounding electrode conductor must be at least 6 AWG copper. The size of the equipment grounding conductor is determined by NEC Table 250.122 based on the rating of the overcurrent protective device protecting the circuit. For example, if the overcurrent protective device is rated at 20 amps, the equipment grounding conductor must be at least 12 AWG copper. The minimum size of the bonding jumper for metal water piping is determined by NEC Section 250.104A. It must be sized according to NEC Table 250.102 cone, based on the rating of the service entrance conductors. The resistance of the grounding electrode system should be 25 ohms or less. If the resistance is higher than 25 ohms, an additional grounding electrode is required. The grounding electrode conductor must be continuous, without any splices or joints. If a splice is necessary, it must be made using a listed irreversible compression connector. The grounding electrode conductor must be protected from physical damage. If it is exposed to physical damage, it must be installed in conduit or other suitable protection. The grounding electrode conductor must be securely fastened to the grounding electrode. The connection must be made using a listed grounding clamp or fitting. The grounding electrode must be located as close as practicable to the service entrance. The grounding electrode must be accessible for inspection and testing. The grounding electrode must be protected from corrosion. If it is exposed to corrosion, it must be coated with a suitable corrosion-resistant material. The grounding electrode must be installed in a location where it will be permanently moist. The grounding electrode must be installed in a location where it will not be subject to freezing. The grounding electrode must be installed in a location where it will not be disturbed by construction or excavation. The grounding electrode must be installed in a location where it will not be a hazard to people or animals. The grounding electrode must be installed in accordance with the manufacturer's instructions. The grounding electrode must be inspected and tested periodically to ensure that it is functioning properly. If the grounding electrode is found to be defective, it must be repaired or replaced. The grounding electrode system is an essential part of the electrical system. It is important to install and maintain it properly to ensure the safety of people and property. Grounding is the intentional connection of a circuit or equipment to the earth. Bonding is the intentional connection of metal parts to create an electrically conductive path. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. The purpose of bonding is to equalize the voltage potential between metal parts, preventing voltage differences that can cause electrical shock hazards. Grounding and bonding are required by the National Electrical Code, or NEC, to ensure the safety of electrical systems. There are two main types of grounding systems: system grounding and equipment grounding. System grounding is the grounding of the neutral conductor of the electrical system. Equipment grounding is the grounding of metal parts of the electrical system, such as metal enclosures, conduits, and equipment. System grounding is required for most alternating current, or AC, electrical systems. Equipment grounding is required for all electrical systems. The grounding electrode system consists of the grounding electrode conductor, and the bonding jumpers. The grounding electrode is the conductor that is used to connect the electrical system to the earth. The grounding electrode conductor is the conductor that connects the grounding electrode to the electrical system. The bonding jumpers are the conductors that connect metal parts of the electrical system together. The grounding electrode must be one of the following types of electrodes: a metal underground water pipe, a concrete encased electrode, a ground ring, or ground rods. The grounding electrode conductor must be sized according to NEC Table 250.66. The bonding jumpers must be sized according to NEC Table 250.102c. Grounding and bonding must be performed by a qualified electrician. Improper grounding and bonding can be dangerous and can lead to electrical shock hazards. Ground rods are typically made of copper or copper-clad steel. They are available in different lengths and diameters. The most common length is 8 feet. The most common diameter is 5/8 inch. Ground rods should be driven into the earth until they are at least 8 feet below grade. If rock bottom is encountered, the ground rods can be buried at an angle not more than 45 degrees from vertical, or they can be laid horizontally in a trench at least 30 inches deep. The distance between ground rods should be at least 6 feet. The grounding electrode conductor, or GEC, connects the grounding electrode to the service equipment. The GEC must be sized according to NEC Table 250.66. The GEC must be continuous, without any splices or joints. The GEC must be protected from physical damage. The GEC must be securely fastened to the grounding electrode. The GEC must be accessible for inspection and testing. Bonding jumpers are used to connect metal parts of the electrical system together. Bonding jumpers must be sized according to NEC Table 250.102c. Bonding jumpers must be securely fastened to the metal parts. Bonding jumpers must be protected from physical damage. Bonding jumpers must be accessible for inspection and testing. Metal water pipes can be used as grounding electrodes. If a metal water pipe is used as a grounding electrode, it must be in direct contact with the earth for at least 10 feet. The metal water pipe must be bonded to the service equipment. Concrete encased electrodes can be used as grounding electrodes. A concrete encased electrode must be at least 20 feet long and must be encased in at least 2 inches of concrete. The concrete must be in direct contact with the earth. A ground ring can be used as a grounding electrode. A ground ring must be at least 20 feet long and must be buried at least 30 inches below grade.